He's the myth, he's the legend, he's the scientist with all the answers and all the questions. It's time for another episode of Alex's Science Corner.
The studio audience doesn't even have to keep up anymore. Thank you.
Alex, what's going on in the wide, wide world of science, my friend?
So, we're going to do some science roundups for today. First up, the Parker Solar Probe has completed its first deep dive towards the sun. And it's right now in its data transmission phase. It's going to spend the next couple months transmitting the data it got from its deep dive through the sun. So they got a lot of data. Now, the first stuff that they're sending back is a really interesting picture of a solar flare, and Jupiter is in the picture also.
Ooh.
The real data that they need to start examining, like I said, it's going to take a few months before it transmits all that data, and then it's going to be a couple months after that before they start getting the first indications of what they're trying to collect. And they're supposed to do like about 20 of these close dives. So it's going to be years before they get all the data, but it is sending back the data, so everything looks like it went well for the first dive into the sun for the Parker Solar Probe.
Very cool.
Yeah, that is real cool. And how do they've got control of it so that it doesn't get pulled in to the sun?
Well, that's what an orbit is.
No.
So it's orbiting.
No, but when it's doing the deep dive, it's
that's an orbit.
Oh, okay.
You see, it's why the moon doesn't fall into the Earth.
Never mind. Go on.
Yeah,
What's
they
the
have
next
control because if they didn't have the shield facing the sun, the heat from the sun would rip apart the satellite. So they always, while it's going around the sun, they have to have the shield facing the sun. Other than that, it's not falling into the sun. It technically is falling, but then it comes around the other side and it falls back up again.
I think what I'm trying to say is I'm just amazed that they've got the technology to keep it from being pulled, to know how far to send it without being pulled in.
Well, that's what they're hoping to get. I mean, that's kind of what they're guessing. It's like we were going to send it this close to the sun. It's not so much as pulled into the sun because that's all stuff that Newton figured out 100 years ago. The orbits are that's nothing surprising. They're for the rocket scientists, that's easy enough to figure it out.
Okay.
It's just that you're going next to this humongous nuclear furnace.
Fireball, yeah.
Yeah, and it's going to be, is the craft going to survive being close to a nuclear fireball?
Yeah.
Right.
Yeah, okay.
So next up is how long it takes to collect data. The Dawn probe, which was orbiting Ceres, which passed away a few months ago, got all the data. It's going to take time to figure out, but what they're right now figuring out with the Ceres, which is the dwarf planet in the asteroid belt, they are finding that it has a lot of carbon and carbon minerals on it. And one of the things about that is Ceres was created in the formation of our solar system. So this is material that hasn't changed since our solar system was formed. And they suspect Ceres was formed outside past the orbit of Jupiter and Saturn. So it got drifted into a closer orbit. This is going to give us an indication of what the very early solar system was like when it was first forming. So this is more information that was coming from the Dawn probe. And
the Dawn probe is the one that's gone now outside of the...
No. That was orbiting Ceres, which was in the asteroid belt.
Okay.
And what happened was it just ran out of fuel.
Oh,
It couldn't...
Oh, is this the one that they had to control how it was going to... No, that was, I think, a Mars. I can't remember which probe it was.
No, the Dawn probe was orbiting 2 asteroids in the asteroid belt and collecting information from them. And Ceres was the last asteroid it was collecting information from. And then it ran out of fuel. And once it ran out of fuel, it couldn't keep its antennas pointed at Earth. And at that point, its mission ended.
But is that the one they crashed into one of the... They let it crash into one of the...
No.
Okay, so that's a different probe that I'm thinking of.
No, there's a couple... They've sent a couple probes. There's another probe that has just made contact with an asteroid, OSIRIS-REx, that is going to start collecting data, or actually has just started collecting data. But that one I'm not talking about today, even though I just talked about it today. The last bit of news is NASA's Voyager 2 probe has entered interstellar space. Now, Voyager 2 was launched in 1977. It and Voyager 1 were the first probes that we sent to the outer planets, to Jupiter, Saturn, Uranus, and Neptune. Voyager 1 has already passed out of has passed into interstellar space, is sending information out from interstellar space. Voyager 2 has just crossed over, or actually about a month ago has crossed over into interstellar space.
Now, aren't these the only two that have ever gone interstellar?
Yes. These are the first two. Now, they have not yet left the solar system because they are right now. Interstellar space is. Our sun puts out a lot of particles, a lot of different material. The solar wind goes out from the sun in all directions, although there's a trail behind us. Where the particles from the sun start to interact with the particles of interstellar space, that is known as the heliopause. And it's like a shock wave in the direction the sun is moving through the galaxy. Well, probes have crossed over that point. It's like leaving your house, but you're still in your property. We've still got a bunch of our solar system left to cross, and it's got to come up to the Oort cloud. And they figure that the Oort cloud is a suspected location of comets that orbit the sun, and the Oort cloud is really, really wide, and they expect that the Voyagers will reach the close edge of the Oort cloud in about 300 years and reach the far end of the Oort cloud in 30,000 years. And that's the end of our solar system.
Given they're still
well, so far, I mean, they're going to cross it.
Space is
We're just
big.
not going to. Yeah, space is big.
Space is big.
Space is really big.
300 years. Holy
To
cow.
reach the beginning of the Oort cloud, and then 30,000 years for it to reach the end of the Oort cloud. And that'll be the farthest reaches of our solar system.
So, do you remember the first Star Trek movie? When Voyager 1 came back. Okay, I'll stop talking about it. That's what it reminds me of, though. That first Star Trek movie.
Okay, you have anything else to add, Alex?
It's like a speed bump in the story, isn't it?
Really was deflating. We were talking about something pretty exciting, and then
It is,
And how big space is. Isn't space?
Yeah.
Space is huge.
Space is, it's, yeah.
Well,
right.
It also goes to show you how big our solar system is. If they launched this, they launched the probe and the satellite in 77.
Yeah.
Yeah.
Well, one of the things is it takes 16 and a half hours for transmission from there to reach Earth.
From the
Voyagers right now to reach Earth.
as far as they are.
Yes.
Okay.
So that's the speed of light, 16 and a half hours for transmission to get to us.
Okay.
You have to complain to your cable company. All right. Any other final thoughts on this or the other stories? Besides the Star Trek movie mentioned. No? Okay. If you have any questions for Alex about these stories or anything else science related, feel free to call him right now at 203
837
99
24.